Hey guys, so we are starting chapter 12, Solutions and Molarity Notes, and we're going to start by looking at a picture of the Grand Canyon. So what causes the formation of limestone caves in the Grand Canyon? Anybody know? Erosion, good. What else? Erosion by what? Water. Excellent. So erosion by running water. Good, so erosion by running water. And so there are some sandstone formations and also some limestone formations, especially with the limestone, which is calcium carbonate, that is dissolved by the water. And the other rocks are also dissolved. Yes, Joey, go ahead. Okay, so we're looking at different types of mixtures. Here's our objective. I can define solution, solute, and solvent. So these are the key vocabulary words that you need to have. Um, we learned aqueous solution in chapter 8. That's when water is containing dissolved substances. To go a little bit further, the solvent is that which does the dissolving. What is our most common solvent? Good, water. Thank you, John. So our most common solvent would be water. The solute is what is being dissolved. So that could be lots of different things. At home, that might be sugar. If you're making Kool-Aid, it could be salt. If you're cooking pasta, it could be a chemical in chem lab. The solute is what's being dissolved. And then the solution, that's the mixture of the solute and the solvent. At the beginning of the year, we learned from chapters 1 and 2 that a homogeneous mixture is a solution. So here are some examples. I'll give you a little bit more background about this. We know that the homogeneous mixture has a uniform distribution. So if you think back to our foul water lab, uniform distribution throughout, no chunks, and no, what else? No layers of like oil or different densities. So let's look at some examples of a homogeneous mixture. We could have salt water. We could have sugar water, like Kool-Aid or Crystal Light, something like that. You could have vinegar. Vinegar is also homogeneous. Also, if you want to go biology, your blood plasma. Not your blood, but your blood plasma. And another good example would be tea. So look at the picture here for C. We have a mug of hot tea. What would the solvent be if you're making a cup of tea? What's doing the dissolving? Everybody? Water. Good. What is being dissolved? Tea leaves, tea dust, maybe instant tea powder based on whatever you bought. So the tea leaves. And then my solution would be the hot tea. Does anyone like to add sugar to their hot tea? Honey? Okay, sugar. So hot water. Hot water. Thank you. Tea leaves, and maybe you're putting some kind of honey or sugar in there too. That would be one of the solutes. So honey. Let's just be a physical change. Okay, now let's look at some other types. We have the heterogeneous. So think back to our foul water lab. Our original foul water was heterogeneous. And to define that, we would say it is not uniform. So that could mean there are chunks of stuff floating around. There could be layers, large particles. It also could be cloudy, like we've seen on some things. So it could be cloudy. So looking at a suspension, the definition of a suspension is a mixture in which small particles, so I'll just maybe say with small particles, dispersed throughout a gas or liquid. So make sure you underline that. It could be either a gas or a liquid. So we have some small particles. What could some examples be? Anyone think of one where it's a suspension? this has to be small particles that are dispersed. So in your salt water, the salt actually dissolves and goes into the solution. So the difference here is going to be suspension. There are small particles. I'm going to give you one more hint. Suspensions settle. Suspensions settle over time. Homogeneous solutions do not settle. So a suspension would settle out over time. So let's think of some examples. When you're going to Olive Garden and you're having the salad, the Italian dressing. So an example would be Italian dressing, or if you have Italian dressing in your fridge, don't you have to shake it up every single time? And then it's kind of uniform, but then it'll settle out. Others could be, you also could say muddy water. Muddy water. Anything that's like shake before serving. Orange juice, maybe? We'll say OJ. Okay, and now let's look at the difference between a colloid and a suspension. So suspensions settle, colloids don't. Colloids do not settle. Let's make a note over here. So these do not settle. So that's your main difference. Both are heterogeneous, but colloids do not settle. Definition of a colloid, the long form is substance in which one substance of microscopically dispersed insoluble particles is suspended throughout another substance, it won't settle. That is really long. I'm going to try and shorten that for you. So we're going to say microscopic particles are suspended throughout and we say either don't or won't settle. I guess we should make sure we say that these are insoluble particles. So they're not actually dissolving. We'll make that note too. So small, and we'll say these are insoluble. So both, they are insoluble. Some examples. There are a lot of broad categories. I'll give you an example of some of the categories. The first category we could have would be aerosols. Aerosols include things like fog, clouds, smoke, and also could be like maybe dust in the room. You also have foams. Could be things like whipped cream. Also maybe shaving cream. And we also have things called solid foams. Does anyone know an example of what a solid foam would be? Perfect, styrofoam. And there's one you can eat. That's the one coming up, but it's going to be styrofoam, and you could eat the cornstarch one. Marshmallows. Marshmallows. Those are a solid foam. Please don't eat insulation. Like spray foam? Yeah, I think that would count. We also have emulsions. Next category, emulsions. This would be homogenized milk, not raw milk. The milk you buy in the grocery store has been homogenized. So homogenized milk also includes mayonnaise. Types of lotion. And then we also have gels. Gels include gelatin, as you would guess, butter, and also jelly. Or maybe you could count jam too. That's how big the seeds would be. So just some more examples. The main thing that I want you to keep in mind is that colloids do not settle, suspensions settle. So if it's heterogeneous, that is your main difference. Yes, Leo? Homogenized milk. It means it's been processed so the milk and the cream don't separate. Good. Okay, I'm going to pause here on page